Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this video lesson, we're going to be looking at using MATLAB to create Taylor series for us. And when you do a Taylor series, you have to expand, it's a polynomial expansion about a certain point, your expansion point. If you choose the expansion point to be x equal to 0, then it's technically called a Maclaurin series. So we'll first look at that, and then we'll look at expanding around different points. Because I'm taking a function and returning a function, this is all symbolic, so I need to tell it. So I'm going to tell MATLAB that I'm working with symbols, so SYMS. And then the variable I'll be using is x. I don't have to use x, but I just need to tell it whatever I'm doing. And I could do this with multivariable functions also. All right, so let's define a function f equals the exponential of negative x. Okay, and it gave me that incredibly not edifying f equals exponential of negative x right back. So let me teach you one other thing that if you're new to MATLAB is really useful, makes it less annoying. So f equals exponential of negative x, and then I can end with a semicolon, and it doesn't do the repeat after me game. Okay, so that's it saves a lot of stress using this. If I want to do a Taylor series, and I just say Taylor of f, it will give me a polynomial expansion. Now what it's going to do is it's going to give me up to the 6th order. Okay. In this particular case, that's great. It's pretty easy to read. I can also, though, look at it using the pretty function. I think pretty function is sort of fun. Okay. Oh, pretty of f. No. Pretty Taylor of f. And it writes it more like you would read in a book or something like that, where it writes it as fractions written over each other instead of with the caret notation and all in one line. So that's the pretty function. I can also, though, if I wanted more terms, so I could do Taylor f, and if I wanted a higher order, then with single quotes, type the word order, then parenthesis, and then how many do we want? Instead of going to this up to 6th as our remainder, maybe I want 10th order to be where I have the remainder. And so it will go up through the first 10 terms. Okay, so I can choose as many terms as I want by doing this. I also can do an expansion around another point. So single quote expansion point. Now this is a little weird because you do a single quote on each side, but then it's expansion point with no space in between. And then comma, and we'll do it around x equal 1. And so it gives me this. Now it's not very pretty. It's not telling me what the numerical value of exponential of negative 1 is. But if we were to evaluate this, we could. But I also get to see what the pattern is, right? So it's the exponential of negative 1 times x minus 1 to the nth power over n factorial. So that's nice. I can, figure out the term. And I could use this if I wanted to do sums or whatever. So I've got that. I can do this, of course, with other functions. G equals sine of x over x. Exponential of g. Scratch that. Taylor of g. And you'll see that it gives me only 3 terms. So what it's doing is it's giving me not the first 6 terms, but it's giving me so that the remainder is in the x to the 6th term. And a sine function is only going to pick up the even-powered terms. A cosine picks up only the odd-powered terms, right? Remember that from math? Okay, so therefore, it's not about how many terms, it's about what the order is on the polynomial. So again, on this, if I were to do Taylor G order 10, it'll give me up through x to the 8th. So x to the 10th is where the remainder is. There's no x to the 9th because there are no odd powers in the sine function. Okay, so that concludes this little video lesson. And our next lessons will be looking at matrices and how we can enter those and work with them. And we'll also start looking at things like how we can get MATLAB to create graphs for us. Thank you very much for your time.